Hello, everyone. In our previous class, we already saw that how to extract the dataset on your regional scale for global climatic dataset. So, in our previous analysis, we classified our in three steps. First step is select best 3 to 5 models from the above selected elegant global climatic model based on performance metrics. Then the second step is ensemble 3 to 5 best model that is selected in first step, and in third step we will prepare precipitation index or temperature index for short-term future, long-term future, and mid-term future. Here is the flowchart that we will use step by step for doing this entire work. So in this lecture, we will try how we can analyze step first step. So we have two data set. One data set that we collected from Bangladesh Meteorological Department rainfall dataset from 1973 to 2024. Similarly, this is saved as Rajshahi Station Rajshahi observation data. And again, we have another dataset that we extract from global climatic model that we already show in our previous lecture or lecture number 2 from same time period from 1973 to 2024. Then we have to import this dataset in our code and run the code sequentially for doing further analysis. So here is the code for daily analysis up to performance metrics. Firstly, we have to reconnect this code and upload here the dataset. I already upload here Rajshahi observation dataset and the global climatic historical dataset. For downloading this, press here and select dataset that you stored here. I stored my dataset in here and select and open. When you press open, automatically your dataset will be open here. So I delete my previous uploaded dataset. Then for importing, select this button and select to dataset and open. Automatically our dataset will be opened here. Then run our code one by one. Initially we import some libraries. If you have different station name, then you have to press here the station name. As I use right now the Rajshahi station, so I do not change the station name. And the global climatic model also SSCN2. So I don't need to change here the global climatic model name. If you use BCC CSMR2, then you have to copy here and paste it here. Like copy and paste here. But right now I will use ACCESSCM2 dataset, so I don't need to replace this name. Then run this dataset. Then the station is Rajshahi and global climatic model is XSCM2. Here is the calibration and validation period. In this dataset, I try to use 80% dataset as a calibration period or testing period, and sorry, train period, and the testing period is remaining 20% dataset. Then here load the Bangladesh meteorological data. Then load the historical dataset that I already uploaded here. Then in this code, we separate our dataset as 80% as a calibration or train period and 20% as test period, and run this dataset. You can change the calibration and validation period also. Then I applied here 4 bias correction method. One is linear scaling, run this code. Another is delta change. Thirdly, distribution scaling, and the last one is XGBoost. After running this code, we will see the performance metrics on validation or test stage. In this dataset, we got the CC value of global climatic model is 0.15 in linear after applying linear scaling 0.15, and the XGBoost is 0.2. Here is the another performance metrics. First, the evaluation matrix shows the accuracy is very lower, and in this dataset we analyzed on daily basis. So as the performance matrix is so poor, so it is better to check using the monthly analysis. How can I mean we have to check after analysis on monthly basis what are the performance matrices we will get. Is it better or same in this manner? Here is some composite skill score for each matrix. From this analysis, it shows that XGBoost is performs better, but it is not well enough. So here is the skill score, based bias corrected method shows XGBoost. And then here we can get some graph. Here is the graph for different performance metrics, and all this output or graph is saved here on output section. Press this 3 button, and here, like if you want to show the scale heat map, press double click. Then you can see the graph for picture. Here is the other picture you can download from here also. So as we do not get the enough performance from daily analysis, we have to move the monthly analysis. For monthly analysis, initially we have to connect or reconnect again. The dataset we upload here, same dataset we upload here, we will upload it here and encode automatically, convert it from daily to monthly dataset. For uploading dataset, I stored here, let's say this is our data from that we collected from Bangladesh Meteorological Department, and this data, the remaining dataset I collected from global climatic model. We select some file that we uploaded here already. Initially, some package I upload, then the station name is Rajshahi, but let's say I will use here MPI ESMI to HR, our dataset. But if I want to analyze ACCE SSCM2, then I have to copy the name from here, and definitely I have to paste it here. And already I uploaded this dataset here. So run this dataset. And here load the meteorological or observed dataset. Then load here Kling-Gupta historical dataset. Then the step 4 is calibration and validation period. Then apply 4 bias corrected method. And then see the next step is to see the performance metrics. Right now, when we see the performance metrics, it is better than the previous one. I mean, better than the daily analysis. Here, the XGBoost correlation is almost 0.7694. In previous time, we got this value is very lower value. and it was 0.20, but right now the value is 0.76. So definitely it is better to use the monthly analysis. Then similarly, here some score metrics, it score analysis, and then output as a CSV file or figure generation. I think this video will be helpful for you if you need this setup code for practicing. Definitely, you can reach me through my email or through comment box. I will try to give all the trusted and code. Thank you for saying this lecture.